Okay, in this next session, we're going to talk about APIs, the cogs behind the machine. So we're really going to dive into APIs generally speaking and look at ASP.NET Web API specifically in a bit more detail. So it all starts with a story about a colleague of mine called Mike Talty. Some of you may know Mike. He's been around Microsoft for quite a while, talking about developer technology. He tends to do a lot of work with Windows and Windows apps, but he's just generally a bit of a genius. And so Mike really helped me out a few months ago, and it's a good story to demonstrate why APIs are worth doing. So it started out with an email to my team. I was preparing this talk and I wanted to show a series of apps using an API. So at the time when I sent this, it was August 2015, and Windows 10 was just been released, and I wanted a Windows 10 app that I could use to work against my API alongside some other apps, which we'll see later on. At the time, I had not really done much with Windows 10, so I didn't really know how to build a Windows 10 app, and really was quite short of time as well. So I sent this email out to my team. It was a kind of a call for help. The specification is this email. I sent this at 12:46 in the afternoon, asking him, can anybody just build a simple UWP app for me? Here's the API. It needs to do this, that, and the other. Let me know. So 37 minutes later, I received this email back from Mike. So Mike had taken my email, read it, gone onto the API documentation, had a look and understood how the API worked, built a Windows app that used that API that did what I wanted it to do, and replied back. He says it needs styles and maybe some responsive UI, but I need to eat, so I stopped there. So brilliant, 37 minutes, and Mike was able to build me an app, and we'll see this app in action a little bit later on today. The reason I'm telling you this is because it really demonstrates why APIs are so useful and so good. And we're going to talk for the rest of this session about what is REST. So REST is an architectural pattern that APIs are built on, or most APIs are built on. We're going to deep dive onto ASP.NET Web API. And then we're going to look at how we've built the API behind the feedback system that you've hopefully all been using to provide feedback on these talks as they've gone along. So firstly, why would you build an API? What's the reason for having an API? Why bother? So this is a scenario of a kind of typical app architecture. So you have a database, you may have a web server which serves a web application to several browsers. Possibly you might have different versions of the site for different browsers. You will have potentially some mobile apps, so iOS, Android, maybe a Windows app as well, maybe other platforms. And the point is here that all of these platforms have their own bits of business logic embedded into them. So without an API, it's up to the iOS app to directly to talk to the database, to get the data from that thing and to do have all the business logic to render it the way it should be on the app itself. Now, the problem with this approach is when the idea guy shows up. So this is an idea guy. This is the guy that kind of taps you on the shoulder and says, I've got an idea for a feature. It won't take you long. Can we just add this thing in? And so when he shows up, you have to go to your application. You have to implement those painful changes, which means generally touching all of these different applications and making some kind of edit to implement that particular feature. And it's quite painful because it's lots of different applications, lots of platforms, lots of languages. It's just not a nice thing to do. So the idea of APIs is that when the idea guy comes along, all of your business logic is contained within the API. So the applications are very lightweight front-end layers on top of the API, which does all the hard work of retrieving and putting data into the database, doing the business logic process, and just the guts of the application, really. And so when the idea guy comes along with that change, it's just a simple change to the API, and then off you go. I mean, okay, yeah, you might have to change the front-end layers as well a little bit, but the changes are much less significant if all of your business logic is contained within the API. And that's really the benefit of APIs, and that's why Mike was able to implement his Windows app on my API so easily, because all of the work was already in the API. So what is REST? REST is an architectural style pattern. It stands for Representational State Transfer. And it's a pattern. It's not a technology that's owned by somebody or built by somebody. You won't find Microsoft REST 0.1. It's not a technology, it's a pattern. It's a way of building software. And it uses the HTTP. So it uses the verbs, the statuses, and the status codes that are fundamental to the way HTTP works in order to work. So it's basically built on top of HTTP, or it's an idea that uses HTTP at its core. And it's uniformed and platform agnostic. So the great thing about REST is if you have a REST API, almost anybody can access that. If they're writing software on a platform that can get onto the internet and make HTTP calls, which almost everything can, then they can use your API. It doesn't matter if it's an iOS app, if it's a web application, if it's some software running on a Raspberry Pi, if it's a Windows desktop application, if it's just PowerShell, it doesn't matter. They can all use HTTP, and therefore they can all get data out of your API in a structured and uniform way. So that's what REST really is. That's the idea of REST. And just to illustrate that, we've got this typical REST workflow here. So on the left, we have a toaster. It is a toaster. I've chosen a toaster here because it doesn't have to be software in the traditional sense. Increasingly, we have technology and applications running on hardware that isn't a PC or a phone. So we're going to use a toaster, and let's say we've got a scenario where we want the toaster to actually effectively print the news, the morning news, on your toast first thing in the morning. Wouldn't that be nice? So let's just say that that's actually a thing. The toaster will make a request to the API. So it's going to go to the API, it's going to say API/news. It's going to send the GET request, which means I want to get information. And it's also going to add this thing called an accept header where it's saying, I want the return to be JSON format, please. So it's requesting some news in JSON format from the API. The API will respond in a HTTP response, and it will say 200 OK, that's the status code. That means I've understood what you've asked me to do, and it's OK. And it will attach a JSON document, which is the actual news. And then the toaster can actually burn the news onto the morning bread, and that's all great and lovely. Now, it seems like a silly scenario, but this is actually a real thing. There is a patent out for a toaster that can actually do this and can burn images and text onto bread. So there we go. And this toaster wouldn't be possible without an API. Although this was in 2008, and I haven't seen them at Argos yet. So maybe there's a little way to go before this actually happens. But there we go. The idea is that any device can contact the API and get the information. So in terms of how it uses HTTP, there's three key things really. There's resources. So the URL that the API, the endpoint of the API is really important in REST. So the URL generally informs the type of information that you want to get. So for example, in the toaster example, we went to /news, which means we want news information. You could go to /products for a product. You could go to /products/87, which might indicate you want the products with the ID of 87. You go to customers, orders, etc. The URL is very important, and the way you structure the URL generally maps onto the entities, either the list of entities or the individual entities that you want the API to return. The next thing we have is a HTTP verb. So this is the instruction you're giving the API as to what you want to do with that resource. So if you go to products with a get, then generally you want to get a list of products. However, if you go to products with a post, you want to post some information to it, and generally post means create a new. So create a new product. If you did a post request to products, you would generally create a new product. If you were to go to product/87 with a get, it means you want to get the information for products with the ID of 87. If, for example, you go to product/87 with a delete, it might mean you want to delete the product with the ID of 87. So the combination, the verb really tells the API what you want to do with the information, and the resource is the entity or the type of information. Now, with verbs, you've got get, put, post, delete. So get is receive information. Put is a partial update. Put is an update. So you would put a new version of the product in place. Post is create new, and delete is obviously delete. Now, there are lots of other verbs as well. So patch is a partial update, and there's lots of other ones that you can use as well. And a good REST API will support as many of these verbs as is appropriate for that type of content. Although most of them do just stick with get, put, post, and delete as the main four that people tend to use. Now, the point here is these are standard things. So this is not something that a company's defined. These are standard HTTP verbs. They're defined as part of the HTTP standard, which you can look at as w3.org. And then the final thing is the status code. So this is the information that the API will respond with. This is the information that gets sent back to the client app to say what happened with the request. So again, these are standard things. They're defined by w3.org. and there's lots of them. So if you do a GET request, you might well expect a 200 OK to that. That's a good response to a GET request because it means, okay, I understand the request. If you did a POST request, which means create something new, you might expect to get a 201 created, which means I've created the thing that you asked me to create. And there's lots of others, and the different sort of regions. So the 200s are all kind of informational. If you've got something like a 500, that's a server error. That means something went wrong on the API. Or a 504 is a gateway timeout, some kind of timeout. You might get a 401, especially if you're doing something like a delete or a post, which means unauthorized. That's telling the client app that you need to authorize to do these things. So the status codes are very important. That's the way of the server communicating back to the calling client application what went on with their request. And so that's REST. And now let's look at actually specifically around ASP.NET Web API. So Web API is Microsoft's implementation of REST. You don't have to use it for REST, but you can use it to build a RESTful API built on ASP.NET. By default, it will adopt the architectural style of REST. So when you scaffold a new API, it has all of the get, put, post, delete actions in there. You can call it from anywhere, from anything, and it can return JSON or XML. By default, it defaults to JSON, but you can make it XML as well. And you can have your own data types in there as well if you want to. It's built on top of ASP.NET. So it uses things like Entity Framework. It uses all of the core features of ASP.NET. So it is part of ASP.NET. It's not separate technology. It has a thing called a model binder. So this is a great way of, if you want, let's say you were to post a new customer, you might have a load of JSON data that you send to the API there. The model binders will bind that JSON data to a full .NET object, which means in your code, you can work with it as if it was a .NET object. The API takes care of all that conversion for you. Likewise, on the way out, it has media type formatters, which means when you return, say, a customer or an order or a product, you don't send JSON back, you just send the .NET object, and the web API will convert that to JSON or XML for you. You don't need to worry about doing any of that stuff in the API. The final thing is it's built on top of MVC as well. So in .NET Core, controllers are mapped to resources. So if you go to /API/news, you would expect to get to a news controller there. The verbs, so get, put, post, delete, those map onto actions in terms of MVC. So you would generally, if you have the news controller, you'd have a get action, a put action, a post action, and delete action. And they're also built in status code. So you can do things like, you can just say return OK, and the web API will convert that to a 200 OK response for you. You don't need to worry about constructing those full HTTP response messages. So it's absolutely built on top of .NET. It does a lot of the legwork for you in terms of making the API specifics. You just work with it really as an MVC controller and let web API take care of the rest. So in terms of .NET Core 1, at the moment we're at release candidate 2, and there are some things to point out at this point. So the first thing is that API and MVC are the same thing in .NET Core 1. They didn't used to be in .NET 4.5 and below, or 4.6 and below. You used to have a specific API controller, but you don't have that anymore. An MVC controller is an API controller. There's no such thing as a specific API controller. So whenever you're creating an MVC application, you are effectively getting all this API goodness for free. At the moment, the tooling's quite behind. Even in release candidate 2, there's certain things that just aren't there, especially in the web API template. So in the web API template, for example, there's no options around using individual security accounts. There's also no scaffolding in the API template. That only exists in the web application template. So it's kind of interesting because MVC and API are the same thing now. You can absolutely use the web application template to build an API. It's just that it's going to give you a lot of MVC stuff that you might not need. So things like Bootstrap and jQuery and views, which you don't need if it's just a pure API. But right now, if you're using .NET Core Release Candidate 2, probably best to use a web application because that's going to give you the most fully featured set of tools. So it is just a tooling thing at the moment. We're hoping that in future versions, the tooling will catch up to where the underlying platform is. But right now, if you're going to download it today, that's the situation that we're in. So now I'm going to take a quick look at creating a new API using ASP.NET Core. So we'll start in Visual Studio, and we're going to go File, New Project. And we're going to choose ASP.NET Core Web Application.NET Core. So this is the cross-platform version of ASP.NET Core, the one that's going to run on Linux, on Windows and Mac as well. We're going to put it in my demo dump folder, and we're going to just call it Web Application 1 and just click OK. I'm going to create this initially as a web application so that I can show you the full power of the API. I will go to use the API template later so you can see the differences, but right now I'm going to use a web application. Notice if I do to authentication, I do have the option to choose individual authentication accounts as well, which means I can either use SQL-based authentication or things like Facebook, Twitter, Google, Microsoft, or other providers. So I'm going to click OK and let that just create. So what we're going to do with this API is that we're going to create a person model. So this is a very simple model that represents a person, and we're going to use the scaffolding to actually create an API controller based on that. So the first thing I want to do is go to models. I'm going to add a new C# class to this. I'm going to call this class person. Okay, I'm going to set some very basic properties up in here. So an ID, a first name and an age. I'm going to set the ID as being the key. Oh, we'll just let that finish restoring packages before I do that. So using component model data annotations, that's fine. So I'm basically annotating that to say that that's going to be the key. So when this gets written into the database, that will be the primary key for the table. I'm just going to try that again. There we go. That's green. That's good. Okay, I'm just going to build that very quickly. So I've got a model now, and what I want to do now is I want to scaffold a new controller based on that model. So I'm going to go to controllers. I'm going to right click, add. I'm just going to wait for a second whilst this builds. Just try to build again. Right click, add, new scaffolded item. Now I've got a few options here. The one I'm going to use for this is an API controller with actions using entity frameworks. This is kind of the full template. So this will write a load of code for you that uses entity framework and does some cool stuff. So this is what we're going to use. First thing it's going to ask me to do is choose the model. So I'm going to choose that person model that I just created. I'm then going to ask for data contacts. This is basically the database. So I'm going to already use one that's already there. The one that's already there is because I added security. So there's already a data context there. So I'm going to just use that. And then I'm going to call it a people controller. So that's a convention. So just like MVC, you would call it the name of the thing, then controller. Okay, that's been scaffolded out now. So let's take a look at what we've actually been given here. So the first thing to point out is that, I'm just going to generate a bit more space here so we can see what we're looking at. So the first thing to point out is that it inherits from controller. So again, we don't have an API controller here. This is just controller, same as any other MVC application. That's the first thing to point out. The second thing to point out is this section here. So this is where we're using the dependency injection model that's new to .NET Core to actually inject the application DB context. So you'll see this without scope to talk about dependency injection in detail here, but just know that we are using that model in our APIs to get our data context. We then have various actions. So we have a get person action here. What this will do is it will return context.person. So it basically return every person in the database as an IEnumerable. We have another get person here, which is going to return a person by ID. So there's some interesting stuff here. So firstly, notice that we've got this HTTP get attribute here. So this means that this action is going to respond to a HTTP get request. And it's going to use ID as the root. So the root will be API/people/ID. Now in the parameters here, we've got this ID and it's prefixed with from root. So it's saying that it's going to get this from the root. It then uses that ID in this line of code here to actually go and retrieve the person with that ID from the database. The next thing it does is notice that it just returns OK. So we're not constructing a HTTP response here, we're just returning OK, and we're passing the person in here. We're not doing any JSON conversion or anything like that. That will get converted to JSON in the back end, but it's the API is doing a lot of this work for me. Again, if we look at the put request, so this is if we're updating a person, so we say HTTP put, and we've got this ID, and we've got a from root there, so we're taking the ID from root, but we've also got from body. So we're taking person from body, which means it's looking at the document that was sent with the request and getting that from the body of the document rather than from the routing parameters. So there's some interesting changes there. Those aside, the code here is almost identical to the code you'd find in 4.5. So some of the structure of the class is different and some of the parameters are different, but the actual code itself is basically just C# code using entity frameworks, nothing that special there. So in order for this to run, I need to actually do some special commands, which we're hoping we're not going to have to do in the final version of .NET Core, but right now in RC2 we do need to do these commands, and they're around entity framework migrations. So at the moment, migrations aren't built into the tooling here. You have to run them in the console instead. So if we just open this project in Windows Explorer here, and I just go to the address bar and type in CMD, it's going to open a console at that location. Now the first thing I need to do is I need to add a migration here. So I can use a new .NET command line. I'm going to do EF to say that I'm going to use the entity framework section of that. Migrations, add initial. So this is going to add my initial migration for the people data that I've got there. Like I say, this is a temporary thing that hopefully in later versions we're not going to need to do in the command line. It will just happen automatically for us. But right now we do need to do this. Okay, so that's great. So that's done. If I go into my project here and go to data and migrations, we can see there it is. There's my initial migration. And this just uses the same thing that migrations used to do with Entity Framework. It has an up and a down, and it just is the thing that basically creates the person table for me. Now I need to actually apply this to my database. So again, I go .NET EF, and I'm going to do database update. So these are the commands that you might have done in the package manager console in 4.5. In .NET Core, you do them in any console using a .NET command CLI. Okay, so once this has happened, this is basically going to have created my database for me, and then we should be ready to go and actually start using the API. Okay, that's done, great. So let's now run the application and see if we can start working with the API. So whilst that's loading, I'm going to introduce Postman. So Postman is my favorite tool for working with APIs. It's actually a Google Chrome extension. Hopefully there'll be an Edge version at some point soon, but right now it's just Google Chrome. I think there's a Firefox one as well. And it's just really good for working with and developing against APIs. So this is just loading the API up. I can see it's localhost 1609. So I'm just going to grab that address here and put it as a GET request. I'm just going to go to API/people initially. So, API/people. So what I'm doing here is I'm doing a GET request to my API/API/people. I'm going to just send that across. Right, so what's happened here is it's responded with 200 OK. You can see the status there, and it's returned an empty array. So of course there's no people in the database now because we've only just created a database, but this is a good response. This means that the server's understood what I've asked it to do and it's responded accordingly. So let's start posting some people. So I'm going to change the verb to post. The URL stays exactly the same. I'm just changing it from a get to a post. And now I'm going to look at the body, and I'm actually going to add in some raw data. I'm going to format that as JSON, and I'm going to add Bob, who's age 35, and I'm going to send that across. Good. So this has responded now with 201, which means it's been created, and we can see that it's actually sent back a confirmation of the thing that was created. So I can see that something that's been created called Bob. The ID is number 1, the age 35. Great. So let's just add a few more people in here. Let's add Bill as well. And then why not add Ben whilst we're here? So we've got a few people in the database now. So if we now revert this back to a GET request and send that, As you'd expect, it's done a 200 OK and it's returned those 3 entities, so everybody that's in the database there. If we go to people/2, which is ID2, it's going to return just Bill there, which is going to that other action where it returns an individual person. Okay, so that's the main .NET Core Web API. So let's just take a look. So we used the web application project there. So let's just take a look at the API project just to see where some of the areas where it's maybe not so complete. So if we just go to new project, again, I'm going to choose the same thing, ASP.NET Core Web Application .NET Core. And I'm going to call this one Web API 1. I'm going to choose the Web API template. So the first thing here is that at the moment, individual accounts isn't a possibility. You can only use work and school accounts, which is basically Office 365 or Windows authentication. You can't use any of the sort of database-based authentication or any of the kind of social authentication providers. Hopefully this will change, but right now in RC2, this is the situation. So we're going to choose Web API. That's going to get created. So a few other areas at the moment, there's no scaffolding here. So we could right click before and do new scaffolded item. That's not an option at the moment in the Web API template. You do have this values controller, and that is basically the same as the values controller from .NET 4.5. And you do have some of these other API features, but the tooling itself isn't there at the moment. It's just not available. So that's a quick look at Web API in .NET Core 1. Next thing we want to look at is some of the things that you can do in .NET 4.5. So we're going to go to older versions of .NET now and just explore some of the powerful features that will hopefully come to Core 1 at some point in the future. But right now they're in 4.5. So if I just close this solution and close this, I'm going to create a new application. This time I'm going to choose ASP.NET Web Application. I'm going to call this one 4.5 and this one API, or I'll call it API 4.5. And this gives me the kind of familiar interface. So I've got the very latest version of the ASP.NET 4.x framework, which is 4.6.1. And I'm going to choose Web API here. So notice straight away that I can have individual user accounts. It's using MVC and Web API as well. I'll explain why that is in a second. Okay, so this is now finished creating the default application. So one of the things about these README pages as well, which you might not be aware of, they're worth taking a look at because they're always customized to the version of the project you've just created. So this one will give me lots of information about API, in this particular case 4.5 API. So it's well worth a look at those things before you just dismiss it. So there's a few things to point out here. Firstly, let's just take a look at this thing called a values controller. So this is kind of a boilerplate controller that you get just by default. So a few things to point out. Firstly, this is inheriting from API controller. So in .NET 4.5, there is a specific thing called API controller. But apart from that, it's got all of the general REST actions in there, and it works in kind of the same way as we saw before. Notice that it's using the API root. So this is defined up in the root config. And we set this up as basically the default control, so the web API config. We set this up as API. So by convention, it's always /API and then control and then ID. So if we just run this in Edge, one of the other things that's in 4.5 or 4.6 but not yet in Core is that we have this automated help documentation as well. So there's a section of the application that will look at all the controllers that are available, and they'll automatically produce help docs for you in order to for you to be able to look at and use and see how the API works, which is very useful. So this is how Mike Talty was able to build his Windows app so quickly, because he was able to look at my automated help docs and figure out how the API works. So if we go to the API section here, we can see that we've got the values controller, so all of the different routes are available. So we've got the get values. We can see that if you want that in JSON, it will look like that. In XML, it will look like that. If we get an individual value, this is what we can expect to have a response. You get all of the types and the IDs and things. Post is really useful. So this is where it's saying, if you want to post, these are the things that we want to post in with that value. So it's very useful, very good thing to have there. So let's now start using this API and start doing what we did before and do some scaffolding, create some models. So I'm going to create that person model again. Let me just call this person. We're going to add the properties again. And we're going to resolve this key. Build the project. We're now going to scaffold a controller based on that as well. So if we right click controllers, we do add. We'll just wait for the build to finish. Let's build that again just to be sure. Okay, new scaffolded item. I'm going to choose Web API 2 controller with actions using Entity Framework. Okay, I'm going to choose the model class, which is there. Data context, again, as before, same as what we've got. With this one, I have the option of doing async or not. I always say if there's a tick box that says async, just tick it. Don't worry about it, it's fine. It's always good to have async if you can. And that's going to scaffold the controller out for me now. Okay, so this is very much like what we saw before, apart from it's using API control. It doesn't have some of the detail that we had before, but the code structure is broadly the same. So we've got a get request for people, people by ID, port, post, etc., etc. So let's just run this and start to use it and interact with it. It's no coincidence that it takes a little bit longer for these ones to run. One of the things about .NET Core is it's much faster than 4.6. And even on a local dev environment like this, you can see the difference here in how quickly this is able to run. If we go into API, we can see, okay, if we go into API, you should hopefully see the automated build documentation. So there it is. It's picked up that we've added a controller called people, and it's automatically provided this documentation for us. So we can do get people, which is saying that this is the sort of response that we can expect to get. So this is just really useful feature that is hopefully going to come to core at some point soon, but isn't there right now. If we do post, this is especially useful because it's telling us the actual parameters and the type that's expected, and it even gives us a sample piece of JSON which we'll use in a second to interact with this. So just like we did before, let's open Postman and let's this time take a new URL which is 1801, and let's do exactly what we did before and just do a get request. So that's returned as XML this time, an array of people. It's XML because I've got this accept header on there. Let's take that off and do it as JSON. And so it's 200 OK with an empty array of people. So let's add some people in here. Let's go to our body and let's say, for example, we want to add somebody called Martin, who's age 36. That's me, by the way. Oh, I need to set that to JSON. Okay, that's great. We add the other Martin, who's 33. So I'm just going to change the age there to 33. We'll add my son Jamie, who is 6. And we'll also add my daughter Madison, who is just 4. Post. And now if we change that to get, we should see that we get an array of people there. The 2 Martins, Jamie and Madison there. So that's great. So up to this point, there's nothing that different here. We've got the automated docs, but apart from that, it's basically what we can do in core. Now I'm going to start showing you some other features which I think are quite exciting, which will hopefully come to core at some point in the future. First one is around OData. Now OData is a way of doing query syntax. So let's say we wanted to filter by just people that were called Martin, or people that were over a certain age or under a certain age. Now there's a NuGet package to help us with that, which we can get to using the package manager console. And to install that NuGet package, I just use this command here. The package is called microsoft.asp.net.webapi.odata. I'll just zoom so you can see that there. So that's going to go to NuGet, it's going to install that package for us. And what that's going to let us do is do this kind of OData query syntax on our API. Okay, so that's now installed. You might have noticed that it added a few things to references here as well. So if we go back into our people API, there's a few things we need to do to enable this. So this only really makes sense on the get people where you're expecting to return multiple people. First thing we need to do is we need to enable query attribute. And I just need to resolve that using OData. And then we just need to return this as queryable. So this just means that it's enabled that OData capabilities on this action. So let's run this again and just see what difference that makes. Okay, so the API is loaded, it's on the same port as before. So let's just repeat this same request just to see that it's all up and running. Okay, good, that's responded. So as before, it's returned everything in the database. We've got the two Martins, Jamie and Madison. But let's say we only want to return somebody whose name is Martin. We can add this query string parameter onto here. So I've put filter name equals Martin. So I'm still going to the same controller and action. It's just that I'm filtering where the name is equal to Martin. If we do that, it's going to, oh, it's giving me a problem here. So have a quick look at that. Oh, maybe it's first name. Yes, first name is equal to Martin. So it's only returned the two people that were called Martin. Let's do the same thing. Let's say its first name is Jamie. It's only returned Jamie there. Let's say we want to return only people that are under the age of 30. In that case, I'm going to make it so that it says age less than, which is LT, and 30. And as you'd expect, that's returned Jamie and Madison. So we could do GT for greater than, and let's return the two Martins. So there's a whole syntax of how you can do it. So you can use this for paging, for filtering, for all sorts of useful things. And if you're working with an API where there's a lot of data, this is really an interesting feature that will make life a lot easier. It's not available on ASP.NET Core at the moment. Hopefully it will be at some point in the future. So that's Web API in ASP.NET. So we looked at core and then also some of the things that are in 4.5 that will hopefully come to core. Now we're going to take a quick look at consuming the API behind our feedback system. So you've hopefully used our feedback system during the course of the day. You've given us, filled out the form on the website and given us feedback on our sessions. If you've not done that, please do that. It's very useful feedback for us. And we're going to just take a quick look at how that API actually works and how it hangs together. So if I just close some of these things down a second. In fact, I can close that whole thing down, whole Visual Studio. That API was written in ASP.NET 4.5, and here is the API. So it's a standard 4.5 project. In this case, we've gone for a domain approach. So we've separated our domain or our entities out to a separate project so that we can, when we eventually do add a .NET Core version, we can hopefully use the same domain. But the entities we have here are pretty simple. So we have a thing called an event, which is basically a talk. So this talk on API is what we call an event. It has a title, a description, a speaker, various other things. Events belong to conferences. So this whole thing is called a conference in our API. We have a set of questions, which are the things that we ask on the form, and we have a question response, which is what you send when you respond in your API. So we've got a fairly basic sort of structure there. And if we go into our controllers, we can see that we've got controllers that correspond to most of this stuff as well. So we have an events controller where we get and set the current events and things like that. So we've got get events, get event by ID, and largely these have just been scaffolded code. We haven't really added much functionality to this beyond the standard scaffolding. So it's pretty much a standard project. We've got migrations enabled. In this case, we've got automatic migrations enabled, which means that whenever we change the model, the migrations are applied automatically. So one of the things I'm going to do here is I'm going to use something that's quite cool about Azure. So this is hosted on Azure. This whole API is hosted on Azure. And one of the things that you can do with Azure is you've got the SDKs. You can do live debugging. So I'm going to open up my thing called Cloud Explorer. You can get to this by just searching for Cloud Explorer. There it is, but I've got it already open. I happen to know that this API is under the MS Web Day resource group, and there it is, API/MS Web Day. So what we're going to do here is we're going to start debugging this live API. So we can attach a debugger. So this is actually running in the Dublin Azure data center, and I'm going to attach a live debugger to it so that we can intercept some of the requests that come in through the API. Whilst that's loading, it does take a while to load because it's actually got to go in. I don't actually know how it does it, some kind of magic, but it's going over to Dublin and attaching to that debugger there. And whilst that's loading, I'm just going to go to our website, mswebday.net. And then shortly, once the debugger's attached, I'll go to the feedback button and where we can start using in this case, the Angular app to debug the API. Okay, so it looks like that's now being debugged. So I'm going to set a few breakpoints here. Oh, it's just taking a little bit longer than expected. We'll wait for this browser to finish loading before we start debugging it. Okay, so we are now debugging our live API. So first thing I want to do is if I just expose Solution Explorer again, I want to go to the events controller. I'm going to put some breakpoints in here. So I'm going to put a breakpoint on get events, which is this guy here. So this is going to, whenever any application calls that API, it's going to break at that point. Okay. Next, we're going to go back to Solution Explorer and we're going to use the current event API. So this is one that's used to actually get the current event that's live right now. So we've got get current event and post current event for when we set it. So we just use get current event. Next, we're going to go to the questions controller. This is used to retrieve questions out of the database. So we're going to put a breakpoint on get questions. And then finally, we're going to go to the evaluations controller. So when you submit an evaluation, this is the one that's used. And in this case, we're going to put a breakpoint on the post, which is what happens when you actually submit an evaluation. So all those breakpoints are in now. Let's go back to our website and we'll click on feedback. And straight away, it's hit get events. And the reason for that is because we have a list of events in the Angular app, and this is returning that list of get events. So I'm going to let that one continue. And then it's getting current events. So in order to work, it gets the current event that's live right now and sets that as the default one on the form. So I'm going to let that one continue as well. So what's happened there is the first one, get event, is what populated this drop-down list. The second one, get current event, is how we know that we're on this particular one. It's actually the wrong one, but let's not worry too much about that. And also, get questions is the one that's how we got all of this question details here. So that's the Angular app. What I want to look at now is the actual another application. So I'm just going to delete all of those breakpoints. Okay, and I'll just show the application working for now. So this event called current event. We use this application to set what the current event is. So this is the application, the Windows application that Mike Talty wrote in 37 minutes. So right now it's saying that welcome to the Microsoft Web Platform. That's the wrong event. We want to actually set that to API. So we're going to set that as current event. And now the API is the current event. Now to see this in action, if we go to the current event controller, I'm going to put another breakpoint on the get and one on the post as well. And if we just restart this app, so this is a Windows app, it's not an Angular app anymore. There we go, get current event has been activated. We can actually step through the code. If we go to debug, we can do step over. And we'll see that we've got this current event object. And this is the full .NET object. You can see we've got the conference here with all of the details of the conference. We've got the speaker, the title, and a load of other stuff. So this is a full .NET object. And if we continue through, it's going to return OK, and it simply passes that full .NET object into the return response. And the web API itself is going to return that as JSON for me and let my app continue. I just need to restart the app there. Let that one go. So if we want to set the new project as being the current one, I can just set it and do set as current event. This is now going to do a post. So it's posted in the ID of what it wants to set as the current event. And this code just simply sets that in the database and lets that continue. And then does another GET request to get the current events. So that's a very simple example using a Windows application. The final application I wanted to show to you here is an Office application. So we're just going to delete all of these breakpoints. Now we have an Office application here for understanding the feedback, but before I go to that, I just want to look at the controllers that are involved in here. So we have the events controller, which we're going to do get all events, and we use the evaluations controller as well. And we're going to do get evaluation as well. Put a breakpoint on that. Now I've got the Office application loaded here in a separate window. If I just start this up, now Office applications are basically web applications that are framed inside Office. So this one's going to launch into Excel by default. It's going to load us in the task pane there by default. And straight away we've hit that API again. So the same API we've used a couple of times already, it's been hit by Office now instead of by something else. And that's given us that list of events there. And when I click on an event, it goes and gets the detail of that event. I can do various other things with it as well. So that's a few different APIs being shown there, a few different applications that are using the same API. And that's really the benefit of API. So we've covered a lot there. We've looked at what is REST, just in principle, the idea that it's an architectural style or a pattern. We've looked at ASP.NET Web API, so we've looked at what the state right now in core with release candidate 2. And we've also looked at some of the features that are in 4.6 that have not yet found their way to core. And depending on what you're trying to do, it will inform which version of that you use. And we then finally looked at our own API that power the systems behind putting on these events.